Mi amo, te amo, mi amo, yo, ay. Zion and mi amo, Jabingi is the motto. The bass gon' puff you up, you like it tough.
Hey guys, how's it going? And welcome to just one more Linux. Today we're going to be doing Cisco Packet Tracer Lab 6.6.7, which discusses configuring PAT or PAT. To get started out here, this is again part of Chapter 6, which discusses NAT or NAT. Okay. This specific lab is the final one in the series, 6.4, 6.5, and 6.6, which discusses specifically PAT. In this lab, we're going to configure Dynamic NAT with overload, verify Dynamic NAT with overload implementation, configure PAT using an interface, verify PAT interface implementation. Okay, so this lab has text that accompanies it. This is not really an entry in the chapter, more so it's part of the lab, right? This is to help you understand and implement what is going on. So before we do the lab, which is right here, we are going to read through a little bit of that text and just analyze some of that stuff. I do recommend doing both static and dynamic versions of this lab first before you do this, so that you have a full understanding of what's going on. I'm not going to backtrack. So, if you would like to learn about those, you're going to have to, watch those videos. There are some things that overlap in this video, so maybe worth it, may not. Anyways, without further ado, let's get started here. Alright, so our PAT scenario. In this topic, you'll learn how to configure and verify PAT. It includes a packet tracer activity to test your skills and knowledge. There are two ways to configure PAT. Depending on how the ISP allocates public addresses, in the first instance, the ISP allocates a single public IPv4 address that is registered for the organization to connect to the ISP, and in the other, it allocates more than one public address to the organization. Both methods will be demonstrated using the scenario shown in the figure. You want to pause on that figure so you can check it out. I love that Cisco just kind of like let this slip by. It's so funny, man. They're so like serious and proper about stuff, and then like they constantly let shit like this get out. Like I know it's just a graphic on a website, but like still, come on. In 6.62, we're going to talk about configure PAT to use a single IPv4 address. All right. So, to configure PAT to use a single address, simply add the keyword overload to the IP NAT inside source command, which we did in the last two labs and discussed earlier. The rest of the configuration is similar to static or dynamic NAT configuration, except that with PAT, multiple hosts can use the same public IPv4 address to access the internet. For this example, all hosts from network 192.168.0.0 matching ACL1 that send traffic through router 2 to the internet will be translated to address 209.165.200.225. Right? Traffic flows will be identified by port numbers in the NAT table because the overload keyword is configured. And here in this little code block we can see the IP NAT inside source list 1 interface 0.011 overload. Right? See the rest of the commands going. In 6.63, we're going to talk about configuring PAT to use an address pool. Right? So, an ISP may allocate more than one public address to an organization. In this scenario, the organization can configure PAT to use a pool of address for translation. If a site has been issued more than one public address, these addresses can be part of a pool that is used by PAT. A small pool of addresses is shared among a large number of devices, with multiple hosts using the same public addresses to access the internet. To configure PAT for a dynamic NAT address pool, simply add the keyword overload to the IP NAT inside source command. The topology for this scenario is repeated in the figure for your convenience. Take a look at it again. In the example, NAT pool 2 is bound to an ACL to permit 192.168.00/16 to be translated. These hosts can share an IPv4 address pool from the pool because PAT is enabled with the keyword overload, right? So here it talks about analyzing PAT. We'll do that in the lab. We're not going to worry about that here. And here it talks about verifying PAT. Okay, so R2 has been configured to provide PAT to the 192.168.00 client. When the internal host exits router R2 they are translated to an address from the PAT pool with the unique source port number. The same commands used to verify static and dynamic NAT are used to verify PAT, as shown in the example output. The show IP NAT translations command displays the translations from two different hosts to different web servers. Notice that two different inside hosts are allocated the same IPv4 address of 209.165.200.256. The source port numbers in the NAT table differentiate the two transactions. In the next example, the show IP NAT statistics command verifies that NAT pool 2 has allocated a single address for both translations. Included in the output is the information about the number and type of active translations, NAT configuration parameters, the number of addresses in the pool, how many have been allocated. So these commands are not new at this point. If you've been following along with the previous labs and chapter, we're just talking about show IP NAT translations and show IP NAT statistics. We'll use both of those to verify PAT in the lab. Okay, that's it. We're going to get into the lab now. All right. Our objectives: configure dynamic NAT with overload, verify dynamic NAT with overload implementation, configure PAT using an interface, verify PAT interface implementation. In part 1 here, we're going to configure dynamic NAT with overload. Configure traffic that will be permitted. On R1, configure a statement for ACL1 to permit any address belonging to 172.16.0.0. Right? Now, here, conveniently, they provide us with the command system. So, we don't even really have any excuse to not be able to figure this out, as literally the answers are given to it. So, on R1 here, we're going to first crack it open, right? We're going to hit enter, and we're going to hit enable, and then we're going to go into global config mode by saying conf t, okay? Once there, we're going to say access list 1 permit, and we're going to say 172.16.0.0. Now, if you forgot or if you're unfamiliar with ACLs, this second portion here that kind of looks like a subnet mask, which it's not, I keep forgetting what it's called. This functions almost like an opposite of a subnet mask, right? So these zeros mean that these portions of the address are required, and the 255 means that anything up to 255, which is high as it goes, can be in that space, right? So this means that any address on 172.16/16 is permitted, okay? So it's basically the opposite. Where it would normally be 255s here for the network portion, it's going to be zeros instead, all right? There's more to it than that. It's a little bit more complicated, but for the sake of this lab, that's enough to understand, okay? So we're going to put 0, 0, 255, 255, okay? And then you're going to hit enter. And then we're going to move on to step 2. Configure a pool of addresses for NAT. So configure R1 with a NAT pool that uses the two usable addresses in 209.165.200.232/30 address space. And we're going to use the IP NAT pool command. We're going to say IP NAT pool, and then I'm just going to name mine any pool name. I know that's just a placeholder they have there, but makes it easier. I'm just going to say any pool name. You can name yours whatever you want. Name it Super Sparkly Unicorn or Pikachu or Pooh Head. Who cares? Name whatever you want. So we're going to say IP NAT pool. It finds any pool name. And then we're going to say the range. We're going to say 209.165.200.233, and then it's going to be through 209.165.200, and then it's going to be through 234. So again, 2 spaces, whatever. And then we're going to say net mask. And then we're going to say 255.255.255.252 as it is a /30. All right. So then look that over. Make sure you entered the correct addresses there. All right. As I did, I believe. Everything's good to go for me. I'm going to hit enter. You should always check before entering commands like that. The thing is even if you know you typed it right, sometimes you don't, right? And if you check, that saves you if you have to troubleshoot. Know that it was right, you know? Why not? Sometimes it saves stuff from being a huge pain, you know what I mean? And then you get further into the lab and you realize you weren't sure if you entered it right, and you either can't find the command or you just completely forget that, like, oh, maybe I entered it wrong. It's better to just check and be sure, you know? Maybe I'm neurotic. Maybe I'm not. Who knows? So after that, we're going to move on to step 3, and we're going to associate ACL1 with the NAT pool and allow addresses to be reused. So this is where we're going to implement overload. Okay, we're going to say IP NAT inside source list, and that's going to be 1. Then we're going to say pool, and it's going to be any pool name for me. But if you used a different pool name, that's where you'll put that pool name. And then I'm going to say overload. Okay, and this is where we implement overload. Press enter. Okay. Now at this point, you should be up to a completion rate of 45. If you're not at 45, then you've improperly configured something, so you're going to want to go back and troubleshoot, right? If you are at 45, keep moving forward with me. So on step 4 here, we're going to configure the interfaces, right? So let's look at our topology here, all right? We're going to configure the R1 interfaces with the appropriate inside and outside commands. Now this one is going to be a little bit different than the previous labs. We have 3 interfaces connecting, okay? Not too crazy though. So looking at R1, here it is. Oh, I'm trying to hover it and it's got them already labeled. So we have serial 010, G00, and G001, okay? Those are going to be our interfaces that we label which ones are going to be inside and which ones are going to be outside. Alright, I'll leave it up to you until I enter to try and figure that out on your own. So first, we're going to head over to the proper interface. So we're going to start out and we're going to say, I'm going to start out with our serial line. Okay, we're going to say interface serial, and it's going to be 010. Okay, so did you figure it out yet? I'm going to say IP NAT. I just realized it also says it right here. I keep forgetting that all the answers in this lab are included. So yeah, you guessed it, IP NAT outside. All right, then we're going to go over to interface. We're going to do G000. We're going to say IP NAT inside. All right. Then we have one more. We're going to do interface G001. And then here we're going to say IP NAT inside as well. And these are both inside. All right. I tried to be sneaky and give you guys a little bit of a challenge, and I didn't even realize. Maybe I'll block it out for the video. Probably not, because I'm too lazy. Didn't realize the answers were right there. All the answers are on this lab. So there's not really any guessing to this. This is more of a show and tell and learn type of lab, right? So at this point, you should be up to 60%. If you're not up to 60%, I would go back. You configured something wrong, okay? If you are, let's move on to part 2. Verify dynamic NAT with overload implementation, right? So we configured R1, all right? And now we're going to go and we're going to use each of the PCs that use R1 as their gateway and access the web page for server 1. We're going to see if they're successful. So I'm going to use one first right here. I'm going to go to the web browser. I wish you could copy that. 209.165.200.021.5. I don't copy it. How do you? Oh, jeez. Yeah, I hate it last time. Alright, so that's successful. Copy it. Then we're going to do that on other interfaces. The other computers that all use R1, okay? So each one should be successful. Now, if not, if I have an issue, okay? We're going to go back and check. Maybe simulation was trying to figure out where your issue is. Or just reset and start over. Maybe a typo. Typo doesn't issue itself because there's no logic to it. You gotta go back through everything and figure out where your typo was. When I typo, I tend to just reset and re-enter everything again. But anyways, it wasn't too complicated. At this point, if you're still here, all of those connections should have been successful. We're going to move on to step 2, view NAT translations. So let's go back to R1. We're going to exit out of configure interface. We're just going to say end. We want to go all the way back to privileged exec. And we're going to say show IP NAT translations. All right. Now let's see. What is it asking us to do with these? I hate how it resets that one. Notice that all 4 devices were able to communicate, and they're using just one address out of the pool. Pat will continue to use the same address until it runs out of port numbers to associate with the translation. Once that occurs, the next address on the pool will be used. Well, the theoretical limit would be 65,536. The port number field is a 16-bit number. The device would likely run out of memory before that limit would be reached. All right. We can see too on here that all of ours are associated, or all of our outside global ones are associated with port 80. I'd like this to be a little. We can see that our inside global, yeah, it looks is are all associated with 124, 125, 126. I'm sorry, I'm saying 126. It's 1026, 1027, 1025, and 1024. And then the inside locals are all 1025. Outside locals are all 80, and outside globals are all 80. Okay? So, interesting. Okay? Next, we're going to configure PAT using an interface. We're going to, part 3, we're going to configure PAT using an interface. We're going to configure traffic that will be permitted on R2. So this one's going to be different. I don't like how they word that. I wish it was a little bit more descriptive. That's okay. We're going to start out here on R2. We're going to configure a one statement for ACL2 to permit any address belonging to 172.17.00. Now this seems very similar to the first one, but keep in mind, pay attention, that's not 16, 172.17. We don't type the same command because it's not the same. Okay, so hit enable, then comp T to enter global config mode, and then we're going to say access list access list 2 permit, geez, I can't type today, Oh yeah, and also that's the other difference. It's not access list 1. We're going to do access list 2. We're going to do access list 2 permit, and then we're going to say 172.17.0.0, and then we're going to say 0.0.255.255. Okay, check that, make sure it's correct. Then hit enter. Okay. Then on the next step, we're going to enter the R2. I hate when that happens. We're going to enter the R2 NAT statement to use the interface connected to the internet and provide translations for all internal devices. Okay, so in this step, this is where we're going to use overload here. We're going to say IP NAT inside source, and then we're going to say list 2 interface S011 overload. Now, what was different on this command than in the previous one? It's in the title, right? Which is why I was getting it more clear, right? Because we're learning in this, right? This lab is meant for people to we're learning about NAT, and it just says configure PAT using an interface. So that's what's different, right? Here we're using the interface instead of an address, okay? So in this command, right, in the last one, or all the other ones, we configured it using an IP address, right? Where is it here? Here it is. Or sorry, the pool. Here we're using an interface, okay? Then we're going to move on to step 3. We're going to configure the NAT interfaces. Configure R2 interfaces with the appropriate inside and outside NAT commands. All right. So here, can you guess again? Because the answers aren't here this time to help you. But at this point, it shouldn't be that hard. Which interface is going to be the outside? Which ones is going to be the inside? All right. We have S011, we have G000, and G001. I'm going to do serial first, just because I like doing serial lines. I don't know why. I'm a nut, I guess. So we're going to say interface serial 011. And then we're going to say IP NAT, what is it? Outside. Okay. And we have 2 more. We're going to do G00. So we're going to say interface G000. And then that one is going to be inside. We're going to say IP NAT inside. And then we're going to do one last one. Interface G001. And this one will also be inside. IP NAT. Okay? Now that should bring you up to 100%. At this point, if you're not 100%, you fucked something up and you got to go back and figure out what it is. You can troubleshoot, use simulation mode. If you get stuck, just reset it and enter everything again. Not that long of a lab, not too much to enter. So if you are at 100%, we can now go on and verify our implementation and test everything out. Okay? So in part 4, that's what we're going to do. We're going to verify our interface implementation. In step 1, we're going to access services across the internet. From the web browser of each of the PCs that use R2 as their gateway, access the web server for server 1. Were the connection successful? So let's open up PC4 here. And we're going to go to the browser, not the command prompt. I believe I still have, yeah, I paste mine in there. But if you don't paste it, it's going to be 209.165.2015. Successful. Let me test that device. Successful. Okay, one more. One yes, successful. All right. Were all the connections successful? You bet your boots they were. And then in step 2, we're going to view the NAT translations. So view NAT translations on R2. Let's pull back open R2, throw an end in here to go back to privileged exec. And then we're going to say show IP NAT translations. Okay. And here we can see our IP NAT translations on R2. All right. Now, let's compare, right? Compare the NAT statistics on the two devices. Why doesn't R2 list any dynamic mappings? Okay, so let's hit top so this doesn't close. I hate how that does that every time. It's so freaking annoying. All right, so let's open up R1, hit top before we resize it so it doesn't do that on me again. We can look at both and compare them. Okay, so this is R1 up here on the top. Do we even see any difference? Let's see. I don't. They're pretty much the same. Let's see here. Yeah. They seem to be exactly the same. I don't know. You tell me. Why doesn't R2 list any dynamic mappings? How about you see if you can answer that in the comments for me? Provide me with an answer, okay? Show me in the comments. Let me know. Tell me. I don't have any viewers yet, really, so I doubt that's going to happen, but we'll see. Let's see if we can do a few more commands here. Okay. Let's do show run. Right, we can see our configured settings there. Let's do the statistics. That one should be. All right. So what are our statistics here? We have 4 translations. Those are inside interface, our outside interface. Those that we have 2 inside interfaces. 28 hits, 4 misses. No dynamic mappings. Why? Answer in the comments. All right. Also, before we go, might as well go into simulation mode and check it out really quick. Let's see exactly what happens at R2. Right. Let's dissect the packet and find out. I don't know if you guys find that interesting. If you don't, you can totally end the video. No one's gonna make you stay and watch it. I always like to see what it says, just so I know. So we're going to go up to R2. Oh, skipped it. There's the juice. Let's see what this packet says. So on layer 1, gigabit Ethernet receives the frame. On 2, the frame's destination MAC address matches the receiving port's MAC address, the broadcast address, or multicast address. The device decapsulates the PDU frame. The device looks up the destination IP address in the routing table. The routing table finds a routing entry. The destination routing entry is connected. Static route. The device sets destination as the next hop. The device decrements the TTL in the packet. The packet is going from an inside to an outside network. The device looks up its NAT table for necessary translations. The packet matches an inside source list and creates a new entry to the source local address. The device translates the packet from the local to the global address with the matched entry. There we go. The magic is done. The device encapsulates the packet into an HDLC frame. Serial 011 sends out the frame. All right. Well, there you have it, guys. That is the lab. What was this called? I keep forgetting what the fuck it was called. It's not just called PAT. I know it's not. It's called Configure PAT. I don't know about you, but for some reason I hate saying Pat. It reminds me of some guy I knew in high school named Pat. Every time I say it, I just picture him and his fucking frumpy face. I hate saying Pat, and being as I think we have a few other labs in this chapter about NAT, but I don't think any of them have anything to do with Pat. So, fuck Pat. I hope you enjoyed the lab. Have a nice night, guys. Take care, or day, or morning, or whatever it is for you. I hope it was good. Enjoy. Thank you.